teachers and students. In our last experiment, we talked about the ideas of expansion and contraction. And we learned that when molecules get heated, they expand and move farther away from each other, taking up more space, and the balloon got bigger. On the other hand, when molecules are cooled down, they get closer together, they contract, which caused that balloon to get smaller when it was put into ice water. Well, that's the reason that thermometers work. Thermometers have a bulb of liquid and a thin tube. And as that liquid is heated, it tends to expand. Those molecules get faster and faster, and they move further apart and travel up that glass tube. But if you cool down the liquid the thermometer is in, it cools down the molecules, they move more slowly, and they tend to pack together and contract. And we're going to make a working model of a thermometer today. For this, you're going to need a small water bottle. You don't want it to be too tall, and you will need a hole in the cap. Here's what that hole looks like. You will also need a straw, and if you can find one that's clear or white, it's better. And you want it to be sized so that that fits perfectly inside that hole like that. Now you have to seal that, and there's many ways to do it. You can use some Play-Doh or clay. I'm going to use a hot glue gun to put some hot glue around that, but you need to be very careful. Not only because hot glue guns can burn you, but because it can also melt the straw, which would damage the experiment. Then you'll need some food coloring and 2 containers of water. This one is ice water, this one is hot tap water. Their temperatures are 3.5 degrees on my ice water. Remember, water will freeze at 0 degrees Celsius, so that's very close to the freezing temperature. The one that I took from the hot tap on my sink is about 40 degrees Celsius, which is about 100 degrees Fahrenheit. Any hotter than that, you could really hurt yourself. So here's what we're going to do. The first thing I have to do is position this straw so that when it's on the bottle, the straw goes down towards the bottom, but leaves about 1/3 of it sticking up at the top. So I want to glue it that way, or seal it somehow. The next thing I want to do is add some water to my bottle, and I want to add enough so that when the straw is placed on there, the bottom of the straw is below the level of the water. So I'm going to fill this one about 1/3 to 1/2 full of water. I'm going to put some food coloring in there because thermometers have colored liquid to make it much easier to see. Obviously, clear water in a glass tube would be very difficult to read. And I'm going to put quite a bit in there so it really shows up. I'm using green food coloring for my thermometer. And I put about 10 drops in there so it'll be nice and dark. I'll be able to see it as it travels up that straw. And like I say, if you can find a clear straw, that's really good. Mine is what's called translucent. So there's a nice dark liquid. Let me see if that's enough, if my straw will go below the surface of that. It's cooled off now, and as I screw that cap on, my straw is below the surface, but just barely. I'm going to add a little bit more water to this. There we go. So the straw is sticking down below the water about 1 centimeter or 2. There's a close-up view of what my thermometer looks like. Now, as I squeeze the bottle, you'll see the liquid travel up that tube. And I can get it to go clear up into the top. But I don't want to squeeze it. That's not what I want to do to cause the liquid to come up. I want temperature to do that. So, now this is the messy part. What you have to do is get some of that green liquid clear up to here and have it stay there. Well, how do I do that? How do I get the liquid up in there? Because if I fill the straw without liquid and then try to put the cap on, it all leaks out. Here's what I found. If I blow in this straw, I put air pressure in here, and then it shoots back up. But you got to get it out of your way when you pull it away from your mouth because it'll spray all over your face. It's kind of fun, really. But you might want to do this outside because the food coloring can stain. I'm going to do it inside. It's okay. But here we go. I'm going to blow in here, and you're going to see the air pressure cause the liquid to shoot up. There we go. Now, you can see that I have liquid up in the top of that straw. You can see it bouncing around there. What I'm going to do now is heat up this water. As I heat the water, it will also heat the air in here. And when that happens, you're going to see that move up further onto the straw. If I cool it down, it will go down below that. So here we go. First of all, I'll heat it up. Now look at that. You can see it moving up the straw. Look at that. The air inside that bottle is expanding, which forces a liquid up the straw. It's a working thermometer. If I take it out very carefully, and notice I'm holding it by the top, I don't want to squeeze the bottle, and I put it in the cold water, let's see what happens. Look at it dropping. Look at that. It's working just like a real thermometer. That's the effect that the ice water has on that. It's going down and down and down some more. You can see where I spilled some water onto the cap when I blew into it and it overflowed. I'm going to let it drop as much as it can. Maybe I can get it to go all the way down below the level of the cap. It's getting closer. Now back to the hot water. And let's watch what it does. There it goes, right back up, just like a real thermometer. And I'm not touching it, it's doing that all by itself. It's getting close to the top. It might even overflow. There it goes. I better pull it out. Let's get it back in the cold water and watch it go again. See, it's all the way to the top. Now it's dropping. Look at that. Just like a thermometer should. So look at that. We made a working thermometer. The temperature goes down in the cold water. The temperature goes up in the warm water. Back and forth, over and over again. It continues to work as those molecules are heated up and expand, or as they're cooled down and they contract. So see if you can make your own thermometer. Be careful sealing that. If you're concerned about using a glue gun, have a grown-up help you, or perhaps use some clay or some Play-Doh or something else to seal that opening. Well, thank you, and we look forward to seeing you at next week's Science Lab.